Okay, in this next section, we're going to talk about types of data. There's a lot of different classifications, but here's a couple of proverbs to get us started. Do you see a man who is wise in his own eyes? There is more hope for a fool than for him. So stay humble in all things is another way of thinking about this. There's a lot of data you might be able to memorize, and there's a lot of numbers that you might actually throw around in a conversation, in hot, just conversations that are just people are flaming at each other. But just remember that, yes, there's statistics, there's information, but stay humble with the numbers that you found, the information that you found that is legitimate, right? Here's another one. The hand of the diligent will rule, while the slothful will be put to forced labor. If you're lazy, you're going to be working hard for a long time. The rulers are the hard workers, in other words. The rulers are the hard workers. And that is to say that there's going to be a lot of vocab words here. Here's the list right here, types of data that we're going to go through. Don't be slothful. Don't be lazy. There is a reason for all this classification. It's because once you've classified, once you identify the type of data that you're working with, that actually opens a lot of doors as to the type of questions that you can ask about that data, about the questions that you're interested in, right? So we're going to go through this, the parameter versus statistic, and then the variables. Variables could be quantitative versus qualitative, nominal data versus ordinal data, discrete data versus continuous data, ratio data versus interval data, and univariate data, meaning one, uni, right? Or bivariate, bi means two, bivariate data. So here's a little diagram as we go through all of this. So data can be classified or categorized as quantitative data or categorical data, meaning it can be numeric in nature or qualities or characters like color, for instance, right? Red, green, orange, blue are categorical. Furthermore, quantitative data could be discrete data or continuous. You can count by whole numbers or you can count by fractions as well. That's continuous. And then categorical data over here would be nominal, just names. There's no order that makes sense to put those names in. Or ordinal, which there is an order that makes sense to put them in. So we're going to go into some more details about this and then break those down even more with levels of measurement. So the first one, parameter. What is a parameter? A numerical measurement describing the characteristic of a population. A numerical measurement describing some characteristic of a population. So when you're studying something and you're studying the entire population, something about the population, but you're studying you have the entire population that you can work with, we call that number that you get out at the end a parameter, right? So 78 out of 100, because you're studying only the 100 people. Then 78 would be a parameter, not a statistic, which is the next one. So in your notes, you'd see population and parameter, and you would type in or write in both of these two words here. The nice thing is, in the English language, P, population, P, parameter. Just remember it that way, right? And same thing goes for statistic. What's a statistic? It's a numerical measurement describing some characteristic of a sample. And there we go. Sample and statistic. Sample and statistic go together. Excuse me. Sample and statistic, S and S go together. So when you are looking at some numerical value that's based off of a sample, that's called a statistic. When you're looking at some number that's based off of the population, that's called a parameter. Here's an examples of parameters and statistics. 51% of the entire population of the U.S. is a female, right? So that underlined part, entire population, references the entire population, and therefore the 51% is the parameter. Based on a sample from the U.S. population, it is determined that 35% consider themselves overweight. So this number 35, because it's a sample, would be called a statistic. 35 is a statistic because it's based off of a sample. So we just went through this first one, parameter versus statistic. So you should understand that a parameter is associated with the population. a numerical value that's describing something about the population, and a statistic is a numerical value that's describing something about the sample that you take of the population. Now let's talk about the types of variables that we can have. We can have numerical, quantitative ones, or qualitative ones. And for the most part, I'm going to use quantitative or categorical. So that's a little bit easier. Let's take a look at those. So first definition, what is a variable? Variable is characteristics of the individual data being measured or observed. So what are you trying to look at? A variable can be color, number of stuff, and it's usually represented by a symbol, an X, Y, and then there's some other S, sigma, mu are the other ones. S, standard deviation in our statistical context. Here's standard deviation of the population. S is standard deviation of a sample. Mu is the average of the population, and we'll have some more to add there, right? So all of these would be something that you can look at, a variable that you're trying to study. Now, when we look at classifying them, we have qualitative and quantitative, or qualitative is the same thing as categorical, and quantitative variables. And they can be distinguished basically by being numeric in nature or categorical in nature. Numbers representing counts or measurements, that is a quantitative data. And qualitative or categorical data can be separated into different categories that are distinguished by some non-numeric characteristics. Again, the easiest example right now would be color, for instance, is non-numeric, right? Some examples, the age of your car. The age of your car would be a numerical data type, so that would be a quantitative data type, whereas qualitative data type would be the eye color of FLC students, right? What eye colors are there? That's not numeric in nature. That is a categorical in nature. Okay, so hopefully we have that. But here's some more examples of numerical, and these are matched here. So the number of toothpaste tubes used per year, the number of is numeric. The brand of toothpaste is categorical, Colgate, Aquafresh, and so forth. GPA for a college major is numeric in nature. College major is categorical. You can see how there's a difference there. Bytes of data uploaded on your phone, that's numeric in nature. Telephone company, that's a categorical type of data. Checking account balance, that's numerical. Checking account location, where did you open your checking account? That's categorical. And lastly, average number of students in a class, that's numeric. And school attended, that's categorical, right? So keep that in mind. Hopefully that builds your intuition some more about the difference between numerical and categorical data types. But here's a stumper, if you will. Think about this. Is an area code qualitative or quantitative? An area code, like a phone number, 360 or 916 or 530, right? Well, if you think about it, even though it's a number, you can't actually perform any mathematical math with it that makes sense. So you can't just add two numerical area codes because that doesn't make much sense. Area codes are actually categorical, not quantitative. They are qualitative in nature, not categorical. So numbers, even though you have a number, could be categorical. Same thing with your student ID number, right? Your student ID number is actually a category. It's not the number of stuff. It's actually describing someone, not the number of stuff. So hopefully that makes sense to you. Here's another example, and this one goes through a little bit more in detail through the vocab words that we've just went through. It says here, of the adult U.S. population, 36% have an allergy, suggesting that it is a representative sample. A sample of 1,200 randomly selected adults resulted in 33.2% reporting an allergy. So if we describe the variable and give its type, that would be, in our case, U.S. adults having an allergy. That would be categorical. So it's literally, do you have an allergy or do you not have allergies, right? Describe the population. Describing the population. Adults in the U.S. Describe the sample. The sample is the 1,200 randomly selected adults. What is the value of the parameter? So the parameter, remember, is associated with the population. And it says here in the very first sentence that of the U.S. population, 36% have an allergy. So that number is associated with the population, therefore it is called the parameter. What is the value of the statistic? That is based on the sample. So there was a sample of 1,200 randomly selected adults, and 33.2% of them claimed to have reported an allergy. That would be the statistic. Number 6, which statement is descriptive in nature? That's the first one. And then which statement is inferential in nature? That's the second one. Why is the first one descriptive? Well, it's just describing something about the population. Why is the second one inferential? Well, you're dealing with a sample, and that number is inferring something. It's making a conclusion about something of the population, right? Namely, what percentage has an allergy. So whenever you're dealing with a sample, the statement will be inferential in nature, and whenever you're dealing with the population, the statement will be descriptive in nature. You're just describing the population because you're dealing with the entire population. So hopefully that helps you build some intuition with these vocab words. Furthermore, qualitative or categorical data can be nominal or ordinal. Nominal just means in name only, just the name. And there isn't actually a reason for you to put those in a certain order. Whereas ordinal data type, there is some order that actually makes sense. So here's some examples to go with that. Nominal data are categorical data where the order of the categories does not matter. For instance, if you looked at a survey and there's a survey question about your race or ethnicity, and you had white, Hispanic, American Indian, black, other, and whatever, the numbers, if you put those in order, it actually doesn't make sense to put those in order. So note that the order of the categories is arbitrary. Whereas ordinal data type, their ordering actually makes sense. For instance, if you see on a survey the scale and you are asked to strongly agree, disagree, neutral, agree, or strongly agree with a certain question or with a certain position. Now, it would be really bad to mess with the person who's taking the survey if you put these out of order, right? You put strongly disagree, then agree, then disagree, then strongly agree, and then neutral. Right? It makes sense that these are categories. They're not numeric in nature, but there is an order that makes sense, right? From strongly agree to strongly disagree, or vice versa. So that is ordinal data type example. Furthermore, quantitative data, and we just dealt with categorical, that they could be nominal or ordinal, and quantitative data could be discrete or continuous. And what that means is discrete is data that results when the number of possible values is either finite, can be countable, right? Or a countable number of possible values. So it's just the number 0, 1, 2, 3, 4. 2.5 is not possible, right? Continuous data type, on the other hand, is a result from infinitely many possible values that correspond to some continuous scale or interval that covers a range of values without gaps, interruptions, or jumps. So you think about an interval of values. Fractions are possible, 2.2, 2.4, 2.7, between 2 and 3. So that's continuous data type. Let me give you some examples. Discrete data type would be the number of eggs that hens lay, for example, 3 eggs a day. You don't hear anywhere where it's not possible to lay 2.5 eggs, right? It's only a whole number amount. Or continuous, the amount of milk that cows produce. For example, depending on your measuring device, would be 2.343115. That's pretty fast. Gallons a day, right? So that is a continuous data type because you can measure parts of gallons or fractions of gallons in that case. Here's some more. When you roll a pair of dice, the only possible values are those 2 through 12. That's discrete data type. There's nothing in between. And also countable, just to make sure you understand this note, countable means that there means a list of numbers that is infinite, but you can actually list them or arrange them in order. So you can still have an infinite number of values and still have a discrete data type. So keep that in mind. As long as it can be ordered there, and it's infinite, it's countable though. Just one more example of continuous data type. James was 25 years old, and then James turns 26. Time is continuous, and therefore at some point he had to be 25.39 years old, right? So keep that in mind. This is continuous data type. So here's what we went through. We looked at data types. Data could be categorical. Data type could be categorical, and therefore it could be just names, categories that doesn't make sense to put in order, or there are names or categories that do make sense to put in order. Data can be numerical in nature, and it could be an interval of values, or data could be numeric in nature and be synonymous with whole numbers, counting numbers, 0, 1, 2, 3, 4, because it doesn't make sense to count fractions or parts of a whole based on the units in the context. Okay. Levels of measurement. Here's the last thing in this section. Levels of measurement, or scale of measure, is a classification that describes the nature of information within the values assigned to variables. That's a all mouthful there. Blah, 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 you're probably thinking. Let me give you some examples to make sure you understand levels of measurement. Some of the same vocab words are going to be used here. Okay, so nominal, ordinal, and so forth. So levels of measurement, here they are, and some examples, and I'll give you a specific example and show you why levels of measurement actually matter, because there's math associated with them. So nominal. Nominal, categories, no ordering or direction. Nominal or a name only. That's one level of measurement. So like religion, gender, make of car, doesn't matter which order you list those types of things, right? Religions, different religions can be listed in any order. Genders, right? Make of car as well. Ordinal data type, ordinal level of measurement, I should say. Ordered categories, rankings, order or scaling in this level of measurement. So your rank in class according to your grade. Team standing in the Pac-10 is an ordinal level of measurement. There's also an interval level of measurement, and that means there are meaningful differences between values, but actually no true zero. For instance, years. I can subtract 1 year from the other to see how many the difference in years is, right? But 0 for years doesn't make sense, right? You just go back in time and keep going. And same thing with IQ, right? I can subtract IQ, but 0 for an IQ doesn't make sense. Same thing for shoe size. Shoe size, you can subtract shoe sizes, but saying a shoe size of 0 doesn't make sense. So no meaningful 0. Whereas ratio level of measurement, you can have ratios, differences, and you can actually have a meaningful 0. So for instance, number of patients seen. That's a ratio level of measurement because, for instance, I can say I've seen twice as much, right, patients as you have. And you can also say in a meaningful way, I have no patients, 0 patients that I've seen today. Number of sales calls, same idea. And then distance to class, right? 0 makes sense. You're in class. So these are the levels of measurement, and there's a reason why we have them. Because with each level of measurement, there's an increase in the complexity of the type of data that you're looking at. You can actually think about it as a ladder or just steps. Nominal attributes are only named. That's the weakest level of measurement. Ordinal attributes can be ordered. That's a higher level of measurement. And interval, distance is meaningful, right? But there's no meaningful 0. And ratio has an absolute 0. That is the highest level of measurement. So let me do this with apples, especially because we live so close to Apple Hills, for instance. You've probably seen a whole bunch of different apples. So if you think about it, give me some things that you would like to study about apples. And there's one right in front of you. What about the different colors, right? So colors, let me just give them to you. Colors, you can talk about how sweet or sour they are. Date picked, and their weight, for instance, right? Each apple's weight. So if you think about this, this is actually the different levels of measurement that we just went through. If you take a look at this, this would be the nominal, just names, doesn't matter which order you put those in. Medium, sour, or sweet are names, are categories, but they have an order that makes sense, right? There's a scale, a spectrum of sweetness to sour, or medium, and so forth. There's a date pick. This is numerical in nature, but there's no meaningful 0. As we said, dates don't, there's no meaningful 0 when you subtract. And then also weight. Weight has a meaningful 0 if you have no apple, for instance, then it weighs 0. And then you can also think about ratios of apples, right? One weighs more, twice as much as the other one. So let me show you now how this is connected with math. Well, when we take a look at math and their symbols, we have equal or not equal signs, less than greater than signs, addition and subtraction signs, and then multiplication division signs. And so with a nominal, if you think about this, all you can do is say that the color is the same or it's not the same. Either the apple is red and the other one's red, or the other one's green and the other one's red, for instance. And so either the two apples are the same or the apples don't have the same color, and that's it. You can't say with color that red is greater than green. You can't compare greatness between color, right? And I'm not talking about, which one is a better color. That's very opinionated. You cannot add a color. Red plus green doesn't mean anything. Yes, we know that, right? Like mixing colors gives you another color, but that's not what happens with apples, right? And same thing with multiplication division. Red times green, it doesn't make sense. Now in the other one, ordinal, a higher level of measurement, we can do some more math with them. So we can say, not only do they have equal sweetness or equal sourness, but we can say that one is actually sweeter than the other if they are different. Now I cannot add sweet plus sour or medium plus sour, and I cannot multiply or divide sweet plus sour, right, in an apple. So, or comparing apples. So that's another level of measurement. Interval level of measurement says date picked, for instance, was an example. We can say, was it picked on the same day or not? Has it been picked for a longer time or not, greater than or less than sign? And we can say, actually do subtraction. What's the length of time between this apple being picked and the other one being picked, and subtract those dates. But multiplying dates doesn't make sense, and dividing dates doesn't make sense, and there's no meaningful 0 with dates, right? And the last level of measurement, ratio, when we look at weights of the apples, yes, we can say that one weighs the same as the other, or one weighs greater than the other. We can add their weights or subtract their weights to find the difference, and we can also take ratios of their weights and also have a meaningful 0. When there is no apple, it makes sense that the weight would be on the scale would be recorded as 0. So these are the levels of measurement, and the reason we have them is because if you think about it, what you decide to study about apples actually implies what kind of math you would be able to do with that category, with that data type, right? Because you are looking at a certain data type, there's a level of measurement associated with that level, with that data type that allows you to do deeper analysis in your statistical process than you would when you would study something else. Again, studying weights allows you to do more mathematically than studying just colors, and that's the whole point behind levels of measurement. The higher the level of measurement, the more math and the deeper analysis that you can do with that. Univariate and bivariate data, really quickly. Univariate data involves just use of one variable, so it does not deal with causes and relationships, right? Because you're only dealing just with one. And bivariate data involves the use of two variables, and this one does deal with causes and relationships. So here's an example of univariate data. How many first-year students attend FLC? That's just one variable. Bivariate data, is there a relationship or association between the number of females in computer programming and their scores in mathematics? Those are two variables, number of and then their scores, right? That's bivariate data. Now, there's some characteristics of data that we should be able to find about our data types, and here are those characteristics. First, the center, and it's called CV dot, if you want to remember this, CV dot. It's not really showing the last part. Time is the last part. Here is the first one, center. A representative or average value that indicates where the middle of the data is. So there's different ways of measuring the center. Variation, a measure of the amount that the values vary among themselves or how data is dispersed, right? Dispersion of data values. The distribution is the nature or the shape of the distribution of data. Is it bell-shaped? Is it uniform? Is it skewed? We'll talk about that in more detail in future sections and chapters. 4, are there outliers? Some sample values that lie very far away from the vast majority of other values. And that last one, time, would be if you did the same thing over again, do you have repeatability or do you get something else? So CV dot is a way to remember that. Checking your understanding. You should be able to answer these questions now at the end of this section. What is the difference between a parameter and statistic? Recreate the classification table for types of data. What's, numerical, categorical, and so forth. Give examples of each of the data types in the table. List the 4 levels of measurement and give an example of each. What is the difference between univariate data and bivariate data? What does CV dot stand for? I really advise that you guys stop this video and then you would go through these questions to make sure you can answer them and be ready for a quiz or test questions, okay? In the next section, we're going to talk about critical thinking, analyzing certain things. And I really hope that you guys, if you do have any questions, post them in the discussion and homework and discussion, lecture discussion, so that those questions can be answered and would help out each other some more. Okay, let's go on to critical thinking 1.4.